Welcome to Chemistry Plumbum. Today we will see hyperconjugation. Let's see the definition. It is a general stabilizing interaction that results from the interaction of the electrons in a sigma bond, usually carbon hydrogen, with an adjacent empty or partially filled p orbitals of pi orbitals to give extend molecular orbital that increases the stability of the system. Let's see below. Let's consider how a methyl group is involved in hyperconjugation with a carbocation center. This is the carbocation center. It means this carbon already loses their one electron. Let's see below. CH sigma bond. The empty p orbital, this is the empty p orbital, associated with the positive charge at the carbocation center is in the same plane. Let's see below. The electrons in the sigma bond can be stabilized by interaction with the empty p orbitals of the carbocation center. Here, see, this carbon already loses their one electron, so this carbon pulling the electron from this carbon. Now bond breaking between the hydrogen carbon atom. Now this carbon has one electron. These electrons going to shift in this positive charge. It makes bond. See in this structure. See here. This sigma bond going to convert pi bond. This is the pi bond. This is the sigma bond. H is going to outside as a H plus ion. Let's see. This diagram shows the similarity with the response and the structure on the right as the double bond, no bond character. Let's see. The stabilization arises because the orbital interaction leads to the electrons being in a lower energy orbital. See here, this is the empty p orbital. It is carbon orbital. This is filled sigma bond. Let's see below. The carbon-carbon sigma bond is free to rotate, and as it does so, each of the carbon-hydrogen sigma bonds in turn undergoes the stabilizing interaction. Next, the ethyl cation has 3 carbon-hydrogen sigma bonds that can be involved in hyperconjugation. The more hyperconjugation there is, the greater stabilization of the system. Example C. Tertiary butyl cation has 9 carbon hydrogen sigma bonds that can be involved in hyperconjugation. Hence, CH3 thrice carbocation is more stable than CH3CH2 plus ethyl cation or ethyl radical. The effect is not limited to CH sigma bonds. This is going to backward. It means carbon hydrogen sigma bonds. Appropriate carbon sigma bonds can also be involved in hyperconjugation. This is the one of the method. Next, let's see another method. This is another method of the hyperconjugation. Let's see the definition for this. It is called no bond resonance or Baker-Nathan effect. Generally, it is called sigma bond to pi bond. This is very easy method. Let's see the ethane molecule CH3CH3. If ethane molecule loses one hydrogen, it is called ethyl radical. See here, this is the ethane. This ethane loses one hydrogen, so we get ethyl radical. This is the ethyl radical. Let's see. So this carbon attained positive charge because here one hydrogen going to outside. We know that hybridization of the carbon let's see below. Hybridization of the carbon. This is the alpha. This is the carbocation. This is the alpha carbon. Let's see below the hybridization. This is the sp2, but this orbital is empty pz orbital. It is carbon p orbital. These both are carbon electron. See here, this one and this one. These both are carbon electron sp2 hybridization. Let's see above. These both electron or these both are hydrogen electron. Please keep it in mind. If you have any confusion, please watch again this video. See here, this is the pz orbital because carbon loses one electron. This orbital is empty because carbon loses one electron. That is carbocation. Please keep it in mind. So structure is going below like this. See here, this is the carbon pz orbital or empty orbital because this carbon loses there one electron. See here, here all are sigma bond. Now this carbocation approach the adjacent second carbon. This is the second carbon. Now this alpha carbon attained the positive charge. Now this alpha carbon attained the positive charge. Again, let's see AgIn. Again alpha carbocation. Now this is alpha carbocation pulling the electron from hydrogen 1. This carbocation pulling the electron from this hydrogen. Now hydrogen going out as H plus ion. Here bond breaking is occurs. So alpha carbon and hydrogen 1 between the sigma bond converted to pi bond. Let's see below. Please, this is the important topic. If you have any confused, please watch again this video. Here, this sigma bond converted to below the pi bond. See here, the pi bond, but now this H hydrogen attained H plus. This is possibility 1. Simply this is called sigma 2 pi bond at pz empty orbitals. Here pz empty orbitals denoted carbon pz orbitals. Suppose if hydrogen 2 going outside as H plus ion, we get below. See now. So this hydrogen going outside as H plus ion, so we get this sigma bond convert to this pi bond. This is a possibility 2. Next, suppose if hydrogen 3 going outside as H plus ion, we get below. It is very easily topic, but see carefully. Here now this third hydrogen going to outside as H plus ion. See here, this third hydrogen going to H plus ion. So now get here pi bond. So this sigma bond converted to here pi bond. This is possibility 3. Let's see, sigma bond converted to pi bond. Let's see another method. All are same, but we written 3 types of method for easily understanding. Let's see the definition. If alkyl group going to overcome of the carbocation in one organic compound, it is called hyperconjugation. Let's see same concept here. See here, this is the carbocation. So this is approach this carbon. Now this carbon hydrogen bond is breaking. So this one orbital going to jump this empty carbon 2pz orbital. Let's see, empty 2pz orbital, because this carbon already loses 1 electron. We know that. See here, carbon 2 loses 1 electron. So carbon attained positive charge. Carbon 2 attained positive charge. Please, let's see this diagram. Next, now electron distribution occurs between the carbon 1 and carbon 2. Carbon 1 and carbon 2. Again carbon 1 attained positive charge, but here did not denoted carbocation. Please keep yourself. Again carbon 1 attain the positive charge. Again carbon 1 pulling the electron from this hydrogen bond. When pulling the electron from this hydrogen bond, they are bond breaking between the carbon hydrogen atom. See below. Pulling the electron from hydrogen. Now hydrogen going out H plus ion. Here bond breaking occurs between the C plus and hydrogen 1. C plus means this is left side carbon. But we did not denote that here. Please imagine yourself. So now after breaking this, one electron jumping to this orbital. This is this carbon empty 2p z orbital. Here all are sigma bond. So this sigma bond going to convert as a pi bond. Let's see below. Please see the image. After jumping the hydrogen 1 going to H plus ion, after jumping this hydrogen is going to outside as a H plus ion. Now hydrogen and carbon between the sigma bond breaking. Here this carbon has only one electron. So this electron and this electron both are going to as a pi bond here. See, this is the pi bond, 2 electron. See, 2 green color electron. This is pi bond, this is the sigma bond. Here not this sigma bond only going to here as a pi bond. This is empty orbital. First this electron jumping here. After this electron going to approach here. It makes pi bonds. Let's see below. Now 2 sigma bond of electron going to pi bond. So we can write simply below. See here. This is carbocation. So this here carbon hydrogen bond breaking. This one electron going to approach here. So now this sigma bond going to as a pi bond. This is the pi bond. This is simple method. Again it is going to backward. See, this is a pi bond, this is a sigma bond, this is a pi bond, this is sigma bond. This pi bond breaking as a or going to as a H plus ion. So again this process repeatedly occurs between the 3 hydrogen atoms and 1 carbon atom. Please, this topic is little difficult or confusion. Please, if you don't understand, please watch again this video. Please note, this is all very important key point. Let's see the first. At a resonance effect, sigma bond does not break anywhere between the molecule. Sigma bond always does not break, but at hyperconjugation, this is resonance effect. But hyperconjugation, sigma bond breaking, then it is going to convert it as a pi bond. What is the resonance effect? Please, we already make the video. If you have time, go search the on our playlist. Here we can say all three hydrogen atoms breaking and gives their pair of electron to carbocation of the empty 2pz orbitals for stabilizing. This is for stabilizing only. So that is why sigma bond converted to pi bond, because stabilizing. It means all three hydrogen atoms try to neutralize the carbocation of the empty 2pz orbital. That's all. See here. This bond hydrogen carbon breaking, and this is the approach here. So now we get here one pi bond. This sigma bond breaking and going to here, see a pi bond. Here H is going to H plus ion. Next, see here, this sigma bond going to as H plus, it means sigma bond going to convert to pi bond. So this hydrogen attained H plus ion, this hydrogen attained H plus ion. Stability order, see, this is methyl cation or carbocation or carbonium ion, very less stable, no extra methyl group. This methyl cation has no any extra methyl group, but here this is called primary. This group has one extra methyl group, so this is stability then methyl cation. Let's see again here, this group has two extra methyl group, 1, 2, so this is more stability than primary, this is secondary. Next, this group has 3 extra methyl group, 1, 2, 1, 2, 3. This is tertiary. This is more stable than first group of methyl cation. Stability order increasing left to right. See, methyl cation and primary and secondary and tertiary. Stability order increase left to right. If one carbocation has less methyl group, it is going to less stability. If one carbocation has more methyl group, it is going to more stability. Next, hyperconjugation at a double bond. See here, this is the double bond molecule. Here this bond breaking and going to unpaired electron, this bond breaking and it is going to the unpaired electron. This is the unpaired electron. It means this carbon has one extra charge, this is minus. So this bond breaking going to as outside as a H plus ion. Again, please if you any confuse, see again the video. Again, here bond breaking between the carbon and hydrogen atom, bond breaking the carbon hydrogen atom. So hydrogen going to as a H plus ion. This is already has one unpaired electron. See here, this pi bond going to outside as a H plus ion. Again this H hydrogen bond approach here, so we get here one unpaired electron. This process as usual repeating process like resonance. Please subscribe our channel, we are making more videos, all are on the way. Please, if you any confusion in this topic, watch again this video. Thanking you all, have a nice day.